Welcome back to the Distributed Generation and Smart Grid lecture series. In this video, we are going to discuss some introduction about smart grid. In detail, what is the architecture of smart grid and other components we will discuss in the another video. But here we are going to discuss something about what makes a grid smart. Today's electric grid was designed to operate as a vertical structure consisting of a generation, transmission, and distribution, as we discussed in the earlier video, and which supported with the control and devices to maintain reliability, stability, and efficiency. However, system operators now facing new challenges, including the penetration of a large number of renewable energy resources in the system, rapid technological change, and different types of market players and end users are also coming into the picture. So in order to deal with all these renewable energy penetration, different kind of market players, end users, etc., we need to think about modernization of our grid in a smarter way. So the next iteration is smart grid. The smart grid will be equipped with the communication support schemes and real-time measurement techniques to enhance the reliability and forecasting, as well as to protect against internal and external threats. So the design framework of a smart grid is based on restructuring the power sector and optimizing its assets. So the smart grid will be capable of handling uncertainties in power transfer across the regions, accommodating the renewable energy resources in a larger way, and it also optimizing the transfer capability of the transmission and distribution network and meeting the demand for increased quality and reliability supply, and it also managing and resolving unpredictable events and uncertainties in operations, and planning more aggressively. You can plan your entire grid. So here we are going to discuss something about some of the definitions of a smart grid. So what makes a grid smart? The digital technology that allows for two-way communication between the utility and its consumers, and the sensing along the transmission line is what makes the grid smart. So the difference between our conventional grid and smart grid is very important thing is communication. That is, a two-way communication is possible between utility and end users. So the consumers can plan accordingly their energy usage and their system constraints. They can plan their energy consumption, and they can communicate with the utility also. So now you know that conventional power system, the only one way communication is possible, where utility communicate to the end user. They are informing the energy charges, etc. We cannot communicate with the utility. So that is, for example, so if you are in case of a customer perspective, if you are already managing activities such as personal banking, suppose if you are using internet banking with your home computer, you can manage your accounts. That is, you can transfer the amount, you can at any time you know the balance amount, etc. You can manage your account at your home with your computer. So in that way, think about electricity. if you can manage electricity by using by sitting in your computer, you can manage your energy consumption. You can check your energy usage, its pattern, etc. That will be very beneficial. uh, Customer will no longer have to wait for monthly statement to know how much electricity he uses. With a smart grid, he can clear and timely picture of energy usage can be obtained using smart meters. Smart meters can able to see how much electricity you use, when you use it, and its cost also you can check. So combined with the real time pricing, this will allow to save money by using less power when electricity is most expensive. So electricity will be charge will be different in a different time of use. So you can plan accordingly so that you can reduce your energy expenses. Or smart grid has the potential to help you save money too, by helping you to manage your electricity use and choose the best time to purchase electricity. And you can save even more by generating your own power also. That is important point. You can generate your own power at distribution level, that is distributed generation based upon any renewable energy resources, and that also you can sell to the utility or grid. All these things you can handle at your home itself using your computer. So everything is you can manage in a smarter way in smart grid. This is one of the conceptual model of a smart grid. This particular model is developed by NIST, that is the National Institute of Standards and Technology. Here we will discuss this architecture in detail in the coming lectures, but you can see the architecture will involve the main stakeholders or main components of this architecture is market, operations, service provider, customer, distribution level, transmission, bulk generation, etc. And what are the functions of each of these particular components we will discuss in later. And you can see one point only at this point of time. You can notice that there will be a two-way communication between these every components in the smart grid. That is there you can see that blue lines, that is actually showing secure communication interface. That yellow dotted line is only the electric interface. So electrically connected or electrical connection is only between customer, distribution, transmission and generation. And but with every components in the smart grid, it is connected through the communication interfaces, so you can communicate each other. Now only we have in our conventional power system only electrical connections are there is no communication between the utility and consumers. Now it is every actions, market or operations or service provider, customer, distribution, transmission, generation, everything is connected to through communication interfaces. And all these data is actually stored in cloud, so that is why it is shown like a cloud domain. We will discuss in detail about this architecture in the coming video. Let us move on to what are the standard definitions of smart grid. Standard definitions of smart grid. In European technology platform, of smart grid, that is which defines smart grid as like this: a smart grid is an electricity network that can intelligently integrate the action of all users connected to it, like generators, consumers, and those that do both, in order to efficiently deliver sustainable, economic, and secure electricity supplies. So, a smart grid employs innovative products and services together with intelligent monitoring, control, communication, and self healing technologies that will ensure following things: that is, the better facilitates the connection and operation of generators of all sizes and technologies. It allows the consumers to play part in optimizing the operation of the system. It provides the consumers with great information and options for choice of supply. Significantly reduce the environmental impact of whole electricity supply system. It maintains or even improve the existing high levels of system reliability, quality, and security of the supply. It maintain and improve the existing services efficiently. It foster market integration towards a European integrated market. Actually, this definition is taken from European Technology Platform for Smart Grid, and the important thing in every smart grid definition is that that employs innovative products and digital technology that will monitor, control, communicate, and self healing itself. Self healing means that whenever a fault or anything can occur in your smart grid, that system itself able to track the problem and clear it. That self healing property is one of the characteristics of a smart grid. Then you can check IEC definition of a smart grid. International Electrotechnical Commission defined the smart grid as: the smart grid is a developing network of transmission lines, equipment, controls, and new technologies working together to respond immediately to our 21st century demand for electricity. So that is the IEC definition of smart grid. And IEEE definition is almost similar to the earlier one. A smart grid is an electricity network that can intelligently integrate the actions of all users connected to it, generators, consumers, and those that do both, in order to efficiently deliver sustainable, economic, and secure electricity supplies. That is the IEEE definition of smart grid. Then how US Department of Energy define smart grid. So smart grid is the electricity delivery system from point of generation to point of consumption, integrated with the communications and information technology for enhanced grid operations, customer services, and environmental benefits. So smart grid is a electricity delivery system. The very important point in every definition is that the integrated with the communication and information technology. That is what is the grid converted into smart grid. The point that converts grid to smart grid. So a smart grid is self-healing, enables active participation of consumers. That means consumers can also involve in the power generation, operate resiliently against attack and natural disasters. That means they can self heal such kind of natural disasters, accommodate all generation and storage options, including our renewable energy power generation, enable introduction of new products, services, and markets that optimize asset utilization and operate efficiently, provide power quality for the digital economy. So that is a very accurate definition of a smart grid that include all the features of a smart grid. And there is a one more definition is known as working definition of smart grid. That is, a smart grid is an advanced digital two-way power flow power system capable of self-healing and adaptive, resilient, and sustainable with the foresight for prediction under different uncertainties. It is equipped for interoperability with the present and future standards of components, devices, and systems that are cyber secured against the malicious attacks. Here they are uh, telling about interoperability means they can work, they can associate it with the existing grid if one or existing grid components also. So a conventional grid can be modernized or transformed from conventional grid to smart grid. Then you can no need to restructure the entire grid, but you can add the component that required for communication and other technologies. You can transform the conventional grid into smart grid. So these are the some of the duties of smart grid. So smart grid or the functions of smart grid or what we are expecting from a smart grid, that is more efficient transmission of electricity and quicker restoration of electricity after power disturbances. That is what is we discussed as a self-healing property. Then reduced operations and management costs for utilities and ultimately lower power costs for consumers. When you are transforming a conventional grid into smart grid, we finally aim lower power costs for consumers by reducing the operations and management cost. Reduce the peak demand, which will also help lower electricity rates. That peak demand you can reduce in a smart grid in a way that the consumers are well aware of their energy usage, so they can adjust their energy usage accordingly, because during the peak period the energy prices will be very high. So in order to reduce the energy prices, they can store the energy during the off peak period, and they can utilize that stored energy during the peak period, and so that will helpful for reducing the peak demand or peak load shaving. Then increase the integration of large scale of renewable energy systems is possible. Better integration of customer owner power generation systems, that is what is we discussing about distributed generation. The customer can also generate power including renewable energy systems. Then improved security is another advantages of smart grid. So let us compare existing grid versus smart grid. So uh, existing grid and smart grid. So existing grid, we are using electromechanical devices, and smart grid is a digital devices. Existing grid, only one way communication is possible. That is, you can communicate. The utility only communicate with the consumer. A consumer cannot communicate to utility. So here, smart grid two-way communication is possible. Existing grid is mainly a centralized power generation. Smart grid is distributed generation. It integrate the distributed generation. Existing grid limited sensors are using, but smart grid we are mostly depending upon the sensors throughout the smart grid. Then existing grid manual monitoring. All of you know that in existing grid self monitoring and self healing. Then existing grid failures and blackouts are there, but in smart grid we are expecting the adaptive and islanding process. That is, they itself identify the problem and disconnect the part of grid which affect the fault, and what is known as islanding. So the entire grid entire blackout is not there in smart grid. So limited control is possible in existing grid, but pervasive control options are available in smart grid. Then existing grid manual restoration. Smart grid is having a capability of self-healing. They can correct their self without any manual interruption and restore the power. So that is what is the difference between a existing grid and a smart grid. And when we are discussing about what is the main components in a smart grid, that is components of smart grid. The major components of smart grid are classified as smart infrastructure, smart communication, and smart management, and smart protection systems. Smart infrastructure, we will discuss these things in later videos in detail, but the things comes under smart infrastructure system is a smart energy system and a smart information systems. And smart energy systems like that include the smart way of power generation, transmission, and distribution. Smart information system will consist of smart metering, smart sensors, phaser measurement unit, information management, etc. And what are the opportunities of smart grid, and why should we transform our conventional grid to the smart grid? So these are the point. Smart grid will help in upgrading the existing grid, or upgrading and expanding the infrastructure to improve the interconnectivity and communications. It helps to build up smart tools and technologies to exploit distributed resources, demand, load control, and energy efficiency. That is demand side management and energy efficiency. It helps in educating consumers. Actually, the two-way communication actually makes a consumer well aware about their energy usage and how to manage their energy usage. Creating models to promote smart grid investment and inform regulatory frameworks. Build up infrastructure to guarantee cyber security and resilience. So, the opportunities of smart grid, opportunities means what are the benefits, or what kind of opportunities it opens to various domains. It can be classified like local opportunities, regional and national opportunities, global opportunities, etc. So we will discuss that kind of opportunities in next video.